Hello everyone, today we're going to be covering the FlareVM Arsenal of Tools TryHackMe room. We're going to learn the arsenal of investigative tools in FlareVM. So let's get started. Also, my name is Joshua Fishak. I'm a cybersecurity analyst and Blue Team content creator. So let's get started with task 1, Introduction. Awesome. Alright, to successfully complete this room, you'll need to set up your virtual environment. This involves starting the lab machine, ensuring you're equipped with the necessary tools and access to tackle the challenges ahead. So let's do that. Start lab machine. Nice. Alright, so what is FlareVM? FlareVM, or Forensics, Logic Analysis, and Reverse Engineering, stands out as a comprehensive and carefully curated collection of specialized tools uniquely designed to meet the specific needs of reverse engineers, malware analysts, incident responders, forensic investigators, and penetration testers. This toolkit, expertly crafted by the Flare team at FireEye, is a powerful aid in unraveling digital mysteries, gaining insight into malware behavior, and delving into complex details with executables. And so here are the learning objectives here. We're going to explore tools inside the FlareVM. We're going to learn how to use tools to analyze potentially malicious processes effectively, and we're going to become familiar with the tools for static analysis of malicious documents and binaries. Additionally, for prerequisites, this room expects that you are familiar with various technical terms related to Windows and processes. If you're unfamiliar with these terms, please consider joining the pre-security path, which we can click here. 2 more. Awesome. Yes. If you wanted to learn more about Windows and processes, the pre-security path is a really great resource, so highly recommend checking that out. Which you can see here. Section 7, 6, 5, 4. The operating system basics and Windows basics. If you click on that, it's going to help you better understand Windows better, so highly recommend checking out the police security path. It has a lot of great rooms to help you build up those fundamental knowledge and just overall really great stuff. Awesome. Alright, VM access. Getting your hands on this tool can be pretty daunting at first, as building it starting from scratch takes a lot of time, and installation will take several hours. Thankfully, we've already included this machine in this room, so you can click on the Start Machine Lab button below, and this should initialize an instance on FlareVM. We will use this tool inside the machine attached to this task, and the machine will start in a split screen view, which can be seen right here. If you opt to access the machine via remote desktop, you may also use the following credentials below. No. Also, if you wanted to see where FlareVM is, FlareVM. And also, here's where you can learn more about it with Google Cloud, and also the GitHub as well to download the FlareVM in much more detail. So here's the GitHub for FlareVM if you wanted to learn more about the installation, etc. Just overall, really great stuff. Very nice. Yeah, it's also being constantly maintained and updated. So like I said, highly recommend checking out FlareVM, and all credit goes to those who make FlareVM what it is. Alright. Almost all the files we'll use in this room are located in the C Users Administrator Desktop Samples folder, which can be found right here. And disclaimer, the FlareVM machine attached to this room contains malicious sample files as part of the practical exercises and has no internet access. These files should not be downloaded, executed outside the FlareVM machine, or distributed under any circumstances. Doing so could potentially harm your system or network. Always handle such files only in isolated, controlled, and secure environments. Alright, I'm ready to learn more about FlareVM. No answer needed. Correct answer. Awesome. Alright, task 2, Arsenal of Tools. Alright, in this task, we'll introduce you to tools inside the FlareVM, which can be found on the right. It has many specialized forensics, incident response, and malware investigation tools. Below are the tools grouped by their category. So starting off, we got reverse engineering and debugging. Reverse engineering is like solving a puzzle backward. You take a finished product apart to understand how it works. Debugging is identifying errors, understanding why they happen, and correcting the code to prevent them. And some tools inside FlareVM for that can be found here. Like Ghidra, X4DBG, OldDBG, Radar 2, Binary Ninja, and PEID. Very nice. Alright, disassemblers and decompilers. Disassemblers and decompilers are crucial tools in malware analysis. They help analysts understand malicious software's behavior, logic, and control flow by breaking it into a more understandable format. The tools mentioned below are commonly used in this category, such as CFF Explorer, Hopper Disassembler, and Rectect. Hopefully I pronounced it right. Alright, static and dynamic analysis. Static and dynamic analysis are two crucial methods in cybersecurity for examining malware. Static analysis, starting off, involves inspecting the code without executing it, while dynamic analysis involves observing its behavior as it runs. The tools mentioned below are commonly used in this category. So you got Process Hacker, PEView, Dependency Walker, and DIE, Detected Easy. Also, I want to provide another really beneficial resource, and that is CyberSec Tools. So basically, if you want to get a better understanding of a specific vendor or tool, this is a really great website, and it's being constantly maintained and updated. So to find out more about malware analysis vendors and tools, you can type malware analysis, hit enter, and we will see just a lot of really great resources such as repositories, vendors, tools, x64DBG, FlareVM, Cuckoo Sandbox, Yara, and we can also view all results for malware analysis. Yeah, right here. Lots of sandboxes and much, much more. So, also there's a second page. Nice. So yeah, like I said, highly recommend CyberSec Tools. They just have a really great directory, so that way you can search on any vendor, category, etc. to help you better understand a specific vendor or tool. Awesome. Alright. Forensics and incident response. Digital forensics involves the collection, analysis, and preservation of digital evidence from various sources like computers, networks, and storage devices. At the same time, incident response focuses on the detection, containment, eradication, and recovery from cyber attacks. The tools mentioned below are commonly used in this category, such as Volatility, RECL, and FTK Imager. Alright, network analysis. Network analysis involves the different methods and techniques for studying and analyzing networks to uncover patterns, optimize performance, and understand the underlying structure and behavior of the network. So you've probably heard of Wireshark, Nmap, or Netcat for that. That's file analysis. File analysis is a technique used to examine files for potential security threats and ensure proper file permissions. And last but not least, scripting and automation. Scripting and automation involve using scripts such as PowerShell and Python to automate repetitive tasks and processes, making them more efficient and less prone to human error. So I got Python and PowerShell Empire. And finally, SysInternal Suite. The SysInternal Suite is a collection of advanced system utilities designed to help IT professionals and developers manage, troubleshoot, and diagnose Windows systems, such as we got Auto Runs, Process Explorer, and Process Monitor. Alright, finally. Have you checked all the categories? There are a lot, right? Oh yes. Worry not, as we won't tackle all those tools right now. It could take months to finish. We want to present you with the concept of having a single box filled with tools for different purposes, giving you an idea of what could work best for a specific task. So in the next task, we will discuss the standard tools used for investigation. Yeah, we got some questions answered. Very nice. Alright, I already completed this room, but don't worry, I'm going to help you understand my problem-solving methodology so that you understand how to get the answer. Alright, starting off with the first question. Which tool is an open source debugger for binaries in x64 and x32 formats? So we're looking for a tool that is an open source debugger for binaries in x64 and x32 formats. Let's scroll up. Okay, look at debuggers and assemblers. Yes, there's assemblers and decompilers. You got CF Explorer, Hopper Assembler, and Rectit. Here we go. x64 DBG is an open source debugger for binaries in x64 and x32 formats. I believe that's going to be the answer. Nice. x64 DBG. And now, what tool is designed to analyze and edit portable executable files? We're just going to scroll up. And CFF Explorer is a PE editor designed to analyze and edit portable executable files. So CFF Explorer. I believe that's going to be the answer. Nice. Alright, which tool is considered a sophisticated memory editor and process watcher? So let's scroll up. Process hacker, sophisticated memory editor, and process watcher. Sweet. Alright, last two. Which tool is used for disk image acquisition and analysis for forensic use? That is going to be... So we're going to look at digital forensics. FTK Imager. Disk image acquisition and analysis tools for forensic use. Awesome. And finally, what tool can be used to view and edit a binary file? So let's scroll up. And we got an HXD, binary file viewing and editing with a hex editor. Alright, moving on to task 3, commonly used tools for investigation overview. Let's examine the tools we will focus in this room, and these tools are the basic ones used for initial investigations. So let's see the list below. We got Procmon, Process Explorer, HXD, Wireshark, that's awesome, CFF Explorer, PE Studio, and Floss. So let's break them down more in detail right here. But just for like more background information, go here, go to AI mode, FlareVM. Could you please break down the static and dynamic analysis tools in FlareVM? Additionally, could you explain examples of how to use the tools in a workflow process from start to finish pertaining to cybersecurity incidents associated with malware analysis? Alright, we're going to break down the tools for static analysis so that we understand how to use the tools for static analysis. And additionally, static analysis involves inspecting a file without executing it to understand its structure, strings, and metadata. So we got PE Studio and PE View, Strings to CyberChef, Kappa, awesome, Udra and IDE Free. For dynamic analysis involves monitoring a tool as it executes in a controlled, isolated sandbox environment. Keywords, controlled, isolated sandbox environment. When you're dealing with malware, you want to make sure you do it in a safe and isolated environment, so that way you don't run like any safety issues, such as because it's malware. So make sure when you're doing malware analysis, it's in a controlled and isolated sandbox environment. And some tools to help you with your dynamic analysis. We got Procmon, Process Hacker, Process Explorer, Regshot, FactNet, FakeNet-NG, yes, that's the thing, Wireshark, and x64 DBG. and an end-to-end malware analysis workflow, so that way you understand like an example of how to do the analysis from start to finish. Again, this is just an example, but I want to provide like a workflow on how to use like the tools. Alright, so this workflow simulates analyzing an unknown suspicious executable, let's just say invoice.exe, be covered during a security incident. Alright, phase 1, we got environment isolation, like make sure your environment is isolated and safe. Then we do static analysis, inspection. We can use like capo, for example, and extract strings. Then we can do a dynamic analysis. We can execute it, and we can analyze behavior outputs such as registry, found process system, network, and also we can do like advanced reverse engineering such as decompiling and debugging. And also incident response reporting template. After completing your analysis, we can compile our findings into a standard incident report to assist the blue team with remediation. Such as, alright. Hopefully that helps you better understand how to use the tools and overall like phases, so that you understand how to use the tools for a, like for example, workflow. Awesome. Alright. So let's get started. Alright, process monitor, Procmon. Procmon is a powerful Windows tool designed to help you record issues with your system apps. It lets you see, record, and keep track of system and Windows file activity in real time. Additionally, Process Monitor is helpful for tracking system activity, especially regarding malware research, troubleshooting, and forensic investigations. So here's how to utilize it effectively for investigation. And according to this log entry, the local security authority subsystem service is a related process, and LSAS has successfully read a file. And for more background information, LSAS handles authentication and frequently communicates with crucial system files such as LSASRV.dll, local security authority server service. And it's important to understand what LSAS is. And don't worry, the sample above does not show any malware signs. And moving on to Process Explorer. Process Explorer offers in-depth insights into the active processes running on your computer. It allows you to delve into the inner workings of your system, providing a comprehensive list of currently running processes and their linked user accounts. If you've ever been curious about which program is accessing a specific file or folder, Process Explorer can provide us with that information. Awesome. And also, as an example, as you can see from the image above, the CFF Explorer app is open. Using Process Explorer located on the desktop here, we identify the process and its parent process. And this is usually pretty useful when we want to monitor what other processes are being spawned, such as from a Word document, an LNK file, or even ISO file, as threat actors typically abuse these. Nice. Alright, HXD. HXD is a quick and flexible text editor for editing files, memory, and drives of any capacity. It can be applied to forensic investigation, data recovery, debugging, and exact manipulation of binary data. Important features include viewing file and memory contents, editing, searching, and comparing hex data. It says look at how the tool works. Very nice. Alright. Example. This HXD hex editor snapshot shows the binary file possible medusa.txt. Please go with it. The hex data on the left, which we can see here, indicates the file's contents in hexadecimal, and the ASCII interpretation appears on the right. Interestingly, the file starts with 4D5A, little endian, indicating it's executable. And also we can learn more about the data inspector. And by permitting in-depth examination of a file's unprocessed hexadecimal data, HXD facilitates inquiry by identifying file kinds, structures, and possible corruption, and its data inspector feature helps by offering insights into particular byte files. Very nice. Alright, moving on to CFF Explorer. With the help of CFF Explorer's comprehensive file information, investigators can generate file hashes for integrity verification, authenticate the source of system files, and validate their validity. This is important to know when analyzing malware, since dangerous code may be hidden in altered system files. As an example, the cryptominer.bin file's details are displayed in the sample. On September 23rd, 2024, a 64-bit portable execution file was generated, and the file's information can be verified by its hashes, SHA-1 and MD5. And during investigations, the tool aids in confirming file information lookup and locating possible problems. We got Wireshark, PEstudio, Flash, and much, much more. So I'm just going to give a quick overview of what these tools are, and then we're going to go do the tasks, which is going to be fun. Awesome. And questions. All right. Wireshark. Regarding network traffic analysis, Wireshark is a powerful tool that investigators may use to hunt down dubious connections, examine protocols, and spot possible assaults or data exfiltration. So if you wanted to learn more about Wireshark, could you please help me better understand Wireshark for network protocol analysis and provide resources into better understanding the filters and provide the URL for these certifications and official website. Yes, Wireshark does have a certification, which is awesome. Alright, Wireshark is the industry standard packet sniffer and network protocol analyzer used to capture, dissect, and inspect raw data traversing a network interface. It translates complex binary streams passing through network cards into human-readable protocol fields, making it essential for network troubleshooting, optimization, and security forensics. So we got the Wireshark official website if you want to check out more about the tool, and just highly recommend it. It's completely free, but please use it for legitimate purposes. Yes. So to get better understanding of Wireshark, we got the certification here. How to learn Wireshark with Chris Gear. Awesome. And Wireshark Essentials. We got a frequency asked question section. Oh, this is awesome. That's pretty sweet. Yes, Wireshark certification. Just really great stuff. I highly recommend checking out Wireshark. It's just a really great tool that I wanted to highlight. And this is how you would understand how to use the filter system as an example, such as capture filters and display filters. So capture filters is pre-capture, and display filters post-capture, and the purpose behind them as well. And also the protocol analysis mastery resources and official Wireshark certifications. Nice. All right, next. All right, PEstudio. Static analysis or studying executable file properties without running the files is done with PEstudio. This feature is beneficial in several situations, such as, for example, PEstudio offers a variety of information about a file without putting users in danger of execution, which aids in identifying executables that seem suspect or harmful. So how does it work? So let's look at the image below. And this image shows the examination of an executable file. Entry value. All right, let's understand this. The dual-use nature of PS exec, typically legitimate but suspicious in compromised environments, combined with low to medium interqueues and moderately high entropy, makes its presence on a system concerning, especially if remote code execution is not expected. Its use in post-exploitation phases warrants further investigation to determine if it's being misused maliciously. All right, moving on. Last but not least, we got Floss. Alright, floss. Using advanced static analysis techniques, the Flare obfuscated string solver, floss, formerly FireEye Labs obfuscated string solver, automatically extracts and deobfuscates all strings from our programs. Like strings.exe, it can enhance the basic static analysis of unknown binaries. So floss also includes more Python scripts in the scripts directory, which can be used to load the script's output into other programs like ID Pro or Binary Ninja. Alright, so let's start with answering some questions below. This is going to be fun. Alright. What tool was formerly known as FireEye Labs obfuscated string solver? Alright. So let's go up. Floss. The Flare obfuscated string solver, or floss, formerly known as FireEye Labs obfuscated string solver, automatically extracts and deobfuscates all strings from malware programs. So I believe that's going to be our answer. Floss. Nice. Alright, which tool offers in-depth insights into the active processes running on your computer? So let's scroll up and try to find the tool that offers us in-depth insights into the active processes running on our computer. Alright, so let's go do that. I believe, let's go scroll up. Awesome tools. Alright, Process Explorer. Process Explorer offers in-depth insights into the active processes running on your computer. It allows you to delve into the inner workings of your system, providing a comprehensive list of currently running processes and your linked user accounts. If you've ever been curious about which program is accessing a specific file or folder, Process Explorer can provide us with that information. Very nice. Sweet. Process Explorer. Alright. By using the Process Explorer tool, under what process can we find smss.exe? Alright, so let's go use Process Explorer. We got Procmon. Yes, this is Process Explorer. I'm going to run as administrator. It opened on the right. That's funny. Alright, let me see if I can view in full screen so that way I can pull. Alright, so it moved, so it just went over there for some reason. Alright, so we're gonna look at smss.exe. And what we're trying to do is using the Process Explorer or proc.exp tool. Under what process can we find smss.exe? Let me exit split view. And that is going to be system. Because under system, we can find smss.exe. Sweet. All right. Which powerful Windows tool is designed to help you record issues with your system apps? So let's scroll up. We got PE Studio, Wireshark, CFF Explorer, HXD. We use Process Explorer, which is awesome. All right, Process Monitor. Process Monitor, or Procmon, is a powerful Windows tool designed to help you record issues with your system apps. It lets you see, record, and keep track of system and Windows file activity in real time. Process Monitor is helpful for tracking system activity, especially regarding malware research, troubleshooting, and forensic investigations. It keeps real tabs on the file system, registry, and thread process activity. So I believe process monitor is going to be our answer. Nice. All right. Pokemon. All right. Which tool can be used for static analysis or studying executable file properties without running the files? So we're looking for a tool that can be used for static analysis or studying executable file properties without running the files. And it is going to be PE Studio. Because static analysis or studying executable file properties without running the files is done in PE Studio. This feature is beneficial in several situations, and PE Studio offers a variety of information about a file without putting users in danger of execution, which aids in identifying executables that seem suspect or harmful. So if you wanted to learn more about a file without executing it, without running the files, PE Studio is the way to go. Nice. Alright. Using the tool PE Studio to open the file cryptominer.bin in desktop sample folder, let's go find the SHA-256 value of the file. So we're going to use Process Explorer. You're awesome. But now let's use PE Studio. Nice. Let me open. Let's go file, open file. And we want to look at cryptominer.bin. So we're going to click on it and then click on open. And we want the SHA-256 value of the file. And we can find it right here. SHA-256. Let me expand this so it's easier to understand. Yes, cryptominer.bin. Here's our SHA-256 value. Nice. Alright, cool. Are using the tool PE Studio to open the file cryptominer.bin in the desktop sample folder. How many functions does it have? Alright. So let's go find out the functions. It is going to have IC resources, IC directories, functions. It's waiting. All right. I believe for this one, I found out that the answer was 102. So we're going to go with 102. Nice. All right, very neat. All right, so let's go with 102. Nice. All right, moving on. What tool can generate file hashes for integrity, verification, authenticate the source of system files, and validate their validity? So let's go find a tool for that. It is going to be CFF Explorer. With the help of CFF Explorer's comprehensive file information, investigators can generate file hashes for integrity verification, authenticate the source of system files, and validate their validity. So I believe the answer is going to be CFF Explorer. Very nice. And using the tool CFF Explorer to open the possible medusa.txt in the desktop sample folder, what is the MD5 hash of the file? So we're going to use CFF Explorer. There's a lot of really great tools. This is awesome. All right, so we're going to look at file, open, and this time we're going to look at possible medusa.txt. Very nice. And we want the MD5 of the file, MD5 hash. It's going to be here. MD5. Here's our value. Nice. And using the CFF Explorer tool to open the possible Medusa.txt file in the desktop sample folder, we will then go to the DOS header section and try to find the e-magic value of the file. So it's going to be, so let's go to DOS header and try to find e-magic, and our value is going to be 5A40. Nice. Alright, task 4. Analyzing malicious files. This is going to be fun. Alright, in this task, we get our hands dirty. So let's dive right in. Using the tools from our Flare lab machine, we will analyze different executables, run them, and see what it does on a specific machine. So, just for some background context, a suspicious Windows.exe file was downloaded by a user on 9/24/2024 at 3:43 a.m. This download was flagged as a potential threat, and the monitoring team has sent you an email requesting to perform an analysis of it. They have sent you the file, which is now in the C user's administrator desktop sample folder. So we're going to use PE Studio. Then we're going to go to Floss, Process Explorer, and Process Monitor. Then we're going to answer some questions. Alright, so I know this is a lot of really great beneficial information. We're going to walk through the investigation together so that way you understand how to use all these really wonderful tools. Alright, so with that being said, let's answer the question. Using PE Studio, open the file windows.exe, and we're going to figure out the entropy value of the file windows.exe. And just for some background context, because we're starting out with PE Studio, we're going to open the file with this tool, and what information can we use here. So let's go here, minimize. We're going to use, I believe it was PE Studio. Yes. So PE Studio. And then we're going to maximize it. File, open file, windows.exe. And we got our file to better understand it from a static analysis perspective. And so for some background information, for the computed MD5 and SHA-1 hashes, comparisons of established databases like VirusTotal are recommended. And to access VirusTotal, you can access it right here. And a really great resource that I want to mention is, I believe I have it, yes, OSINT Navigator. What OSINT Navigator does is that it provides you a lot of really great tools and resources, for example, like different categories such as search tools, IPinfo, threat intelligence, hash lookup, email, and much, much more. So if you don't know like what specific like tool or like resource to use for like a specific like category, OSINT Navigator has a lot of different like categories and tools, and the website is completely free to use as well. So, like I said, highly recommend OSINT Navigator. And just overall, if you wanted to better understand how to use it, there's a guide, which is very nice. All right, so step 1, enter any IP address, domain URL, or hash into the search bar. Then step 2, click the add button, and this will automatically append your input to each relevant OSINT tool's URL. Update all the tool cards of your active links based on your query, and then use any tool that you want to open it, and your search input is already preloaded. And here's bonus tips as well. Very nice. And so we're going to answer the question. Floss, Process Explorer, and Process Monitor. Really cool. We're going to open the file which you have done, and we're going to try to find the entropy value of the file windows.exe. So the entropy value is going to be, so we want the entropy value, it's going to be 7.9.999. And if you don't know what entropy value is, don't worry, I'm going to help you better understand what it is. So, could you please explain entropy value pertaining to malware analysis? All right, entropy value. In malware analysis, entropy is a mathematical measure of randomness or disorder within a file's data. It is calculated on a scale from 0 to 8 based on Shannon's entropy value formula, which measures the frequency and predictability of byte values 0x00 to 0xFF throughout the binary. Analysts use entropy as a rapid detection mechanism to determine if a file has been encrypted, compressed, or packed to invade antivirus scanners. So for like a visual understanding, the 0.0 to 8.0 scale breakdown. So the visual behavior of entropy values helps quickly categorize a file state. So 0, flat, repetitive. 6, standard executable code. And then 6.8 and above. Yes, and above. Please take a look. And here you go. This is the breakdown: low entropy, standard code, and high entropy. And why malware authors use obfuscation and how to scan for entropy in a malware lab, such as like PE Studio, Kappa, and Detect It Easy. And also how to detect a packer as well. Awesome. Hopefully that helps you better understand what entropy means pertaining to malware analysis. So 7.999. Alright, using PE Studio again, we're going to open the file windows.exe, which we have. Then we're going to go to the manifest administrator section to find the value under requested execution level. So let's go back to PE Studio, and then under the administrator section, we're looking for, I believe it was requested execution level. So let's go figure out what value is under that. Requested execution level equals required administrator. Nice. All right. Which function allows the process to use the operating system shell to execute other processes? So let's go look at functions. There we go. 102. So I was right. That is the answer. How many functions there is? So we got a lot of functions. And I believe it's mentioned above. We got a windows.txt file. Let's open PowerShell plus. Alright, here we go. They found us some headers. And to help you better understand what a function is, the functions tab. The functions tab lists API calls that the file has imported. This is known as the IAT, or input address table. And by clicking on the blacklist tab, PE Studio will sort the API by moving all the blacklisted functions to the top. This is useful because it enables us to understand how malware may behave once it compromises a host. The image below shows what API has been imported. Nice. And here are some important functions that we noted. Set use shell execute. This function allows the process to use the operating system shell to execute other processes. This is often seen in malware that spawns additional processes to carry out malicious actions. So we got CryptoStream, manage, cipher mode, and create decryptor. And these APIs indicate that the executable uses cryptographic functions, specifically Rendale, AES encryption, and malware may use cryptography to encrypt communication files or even implement ransomware functionality. So we got managed. Nice. Alright, what is the infdash of kobostrike.exe? So we're going to use PE Studio to find the infdash. And of course, technology wants to be wonky. Sorry, let me load. Connecting to remote machine, yes. I want to use the tools. So why are you not showing me? All right, come on, FlareVM. You can do it. What happens if I do split view? Let's see if that works better. Looks like it doesn't want to cooperate. So I'm going to terminate the machine and open up another machine so we have a fresh instance. So I'm going to go to terminate. I'm going to scroll all the way up. Go to introduction, start lab machine. All right, now we're going to have a fresh instance and hopefully it doesn't like cause us any issues. All right, so now we're going to answer the question. What is the infhash of kobostrike.exe? And for more background information, what is infhash pertaining to malware analysis? All right, here we go. Infhash, short for import hash, is a cryptographic fingerprint generated exclusively from the import address table of a Windows portable executable file. And what it does is that it allows analysts to identify and pivot on related malware samples, even if their original cryptographic file hashes like MD5 or SHA-256 are entirely different due to slight modifications or padding. So this is how an infhash is calculated and why it matters to malware analysis. Analysts like tracking evolving malware families, attribute tooling the threat groups, bypassing policy upload limits, and we got an example. Limitations. Awesome. Hey, look at our machine load. That's sweet. Come on. You can do it. Who doesn't like seeing that logo? Let's go. Alright. Now let's go to PE Studio. Let me click on open. No. File, open file. And this time we're going to look at kobostrike.exe. And kobostrike.exe, click on open. And we're going to try to find the infhash, which is right here. Nice. All right, so what is the defanged IP address to which the process kobostrike.exe is connecting to? And we got a hint. You need to provide the IP address in a defanged format, such as 192.168.3.77. And let me explain why defanged is important. So could you please explain the importance of defanging IOCs pertaining to cybersecurity incidents? All right. So what is defanging? Let me explain. Defanging is the process of intentionally altering indicators of compromised IOCs, such as malicious URLs, IP addresses, domains, and email addresses, to render them unclickable and safe for human transmission. The primary importance of defanging is to prevent accidental execution by analysis, security teams, or automated infrastructure during an active incident response investigation. So, if you want to render like certain like IP addresses, domains, URLs, etc. unclickable and safe, defanging is the way to go. And you can see here some examples of defanged formats for domains, etc. And the tools in which to do that, you can use CyberChef and command line utilities. Sweet. All right, so for this one, we want to use, I believe they mentioned Wireshark. Yes. So let's go find, we can also use Process Explorer and Process Monitor, because in this example, we will analyze the network connectivity of the file kobostrike.exe. So if you wanted to learn more about the network connectivity of the file, so let's go do that. Why is this? Let's see one unified screen. And let me minimize this. All right, in order for us to see that information, we need to run the file, but this is in our lab VM. Okay. So let me just click on OK. And let's go run procmon. Reset, apply. It's already monitoring the system and nothing is running. So let's execute kobostrike.exe. So let's double click it. And we should see some stuff pop up. And I believe, so we need to run kobostrike.exe and open Process Explorer. Alright, so not procmon, so Process Explorer. So that should give us more information about the file. Process Explorer. Nice. And if we expand this, we should see kobostrike.exe. Oh, because I have not run it yet. So let me just run it. All right, kobostrike.exe. There we go, right here. We can see that some stuff spawned right here. All right, let me minimize this just to make it easier. And what we want to do is that we want to figure out the defanged IP address to which a process kobostrike.exe is connecting to. So let's look at this. And can we view more information? Properties. We got kobostrike.exe right here. We got TCP IP information. Ooh, we got a 47.120.46.10.210 IP. Let's go use an IP reputation tool to learn more about it. So I like using VirTotal. Actually, let me show you how to use OSINT Navigator. And we're going to type in 47.120.46.210. Add. And let's go use VirTotal. So we're going to open the tab. Let's go learn more about it. And we can see, yeah, it's very sus. So this looks like indicator reports. Yeah, very, very bad IP. So I believe this is going to be our IP. And if I sign in, yeah, I should get more information, but for the purposes of this demonstration, I believe this is going to be our answer, 47.120.46.210. Nice. And how did you defang it? Let me show you guys. So we're going to take this IP, make sure to copy it here. So right click and copy, then head on over to CyberChef. Then go to input, paste, and then in operations type defang and defang IP address, because it takes an IP version 4 or IP version 6 address and defangs it. meaning the IP becomes invalid, removing the risk of accidentally utilizing it as an IP address. So we're going to put that in recipe. And now we have our defanged answer right here. Sweet. All right. What is the destination port number used by CobaltStrike.exe when connecting to its C2 IP address? So we got, so let's go look at CobaltStrike.exe again. And this time we want to find a port. So let me see. Can I expand? Can I expand this? No, I can't. Okay. So let me see if I can. Oh, we got PCAF. Nice. So let me just double click that so we can use Wireshark. It's going to be fun. All right, give it some time to load. Oh, this interface is awesome. It's doing its thing. Wireshark is initializing. And we should see our information soon. Yes, we do. All right, so now we want to type ip.aer, IP address equals our C2 IP address. So 47.120.46.210. Enter. And let's try to find our destination port. You can see here our first one. We got destination port 81 for transmission control protocol. So let's see if our destination port 81 is our answer. Nice. All right, during our analysis, we found a process called CobaltStrike.exe. Let's try to find the parent process of CobaltStrike.exe, and we have a hint. This is the process when a user personally clicks a binary. So we're going to go to Uses tab. No! Technology, okay. Awesome, so we're going to go to process. Okay, so do I have CobaltStrike running? So I need to execute CobaltStrike, a safe and isolated environment, and we should see CobaltStrike.exe under Explorer.exe. The properties, yes. So Explorer.exe, and then we see CobaltStrike.exe. So let's see if Explorer.exe is our answer. Cool. And just overall, for more beneficial information and how to use Process Explorer, analysis of Process Explorer and Process Monitor, you can find it here, which we have done. We've used Process Explorer to figure out more about the process tree and also the properties as well. We found the IP address. It's for C2. We can show you how to use filters as well. And then we used Wireshark to find the destination port. So if I go here and click this right here using this field. And finally, we use Process Explorer again to find the parent process of CobaltStrike.exe, which was Explorer.exe, because under that we see CobaltStrike.exe as the child process. All right, task 5. Conclusion. Let me exit split view. All right, in this room, we introduced the FlareVM, or Forensics Logic Analysis and Reverse Engineering, which is a complete and customized environment designed for incident response, malware reverse engineering, and forensic analysis. review the installed tools and categorize them based on their purpose. We then discuss some standard tools widely used during investigations such as PE Studio, CF Explorer, Process Monitor, and Process Explorer. Awesome. And lastly, we acquired hands-on experience in analyzing malicious programs or files using this tool. Such as, for example, in the commonly used tools for investigations, we use overall these really great tools like CF Explorer, Wireshark, PE Studio, and much more. We answer the questions. So we got experience understanding how to use the tools such as CF Explorer for static analysis to learn more about the files without executing them. And then we analyze malicious files using PE Studio, Process Explorer, and Wireshark to understand the network connectivity and what happens when the file is executed. So overall, a really fun exercise. All right, fantastic room. I agree. No answer needed. So let me stop. Terminate machine. All right, no answer needed. Correct answer. And some really helpful resources that I want to highlight used in this room are the ones mentioned in the room. And CyberChef, VirusTotal, CyberSec Tools, AI, Wireshark. Here is the GitHub for the FlareVM. All credit goes to them. So hopefully it helps you better understand how to use FlareVM and overall its tools in the box. I hope you enjoyed my walkthrough, and I will see you guys for the next walkthrough. Have a great day. Peace.